Hey, welcome back. So this section, as you may have guessed, we're continuing on with our books data. We're not doing cats, we're doing books. And primarily what we're going to do is focus on some more advanced MySQL features. Things like limiting the number of results that we get back. Instead of 10,000, I want 5. Then we'll see how to do things like sorting our results. I want the top 5 books sorted by sales or sorted by title alphabetically or by genre. All sorts of things we can do. And then from there, of course, at the end, we're going to have some fun exercises and challenges to wrap everything up. So let's get started. All right, welcome back. So in the last couple of sections, we focused on select, and we're going to continue that trend. In this section, we're going to talk about some of the other tools that we'll be able to use to get more specific when we're selecting things. So we'll be able to do things like sort our results that we get back in alphabetical order or reverse alphabetical order, or limit the number that we get, or only get unique results back, and a bunch of other things that we'll be able to combine and use just as other tools in our arsenal, or weapons rather, in our arsenal. So before we do that though, I want to start by just adding a little bit more data to the books that we're currently working with. Basically, I want to have a bit more variety, so I'd like to insert 3 new books, and they look like this. So we have one here, 10% Happier by Dan Harris, released in 2014. We have 29 in stock, and it's 256 pages long. You'll see why we have that, why we're inserting that in just a couple of videos, but there is a reason. We're going to come back to it. And then we have a fake book. So just imagine that we're testing our system or something, and we want to make sure it works. So we have fake_book, and then that's written by Frida Harris in 2001, 287 copies in stock, 428 pages. And then this is actually one, so I haven't read either of these, but this is one I just finished. And that's one of the reasons I added it in. There's another one though. It's really good, by the way, if you're looking for a book, called Lincoln and the Bardo by George Saunders, released just this year. And we have 1,000 copies in stock because it's brand new. So we haven't sold any, or we haven't sold many yet, or maybe we're anticipating a big flood of sales, and it's 367 pages. So either type that up or copy and paste it in. The code's available along with this video. And we're going to just copy and run over here. Make sure that let's make sure we're working with the correct database. All right, in Bookshop. And we'll just paste that in. Insert into books, blah, 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 blah. We don't need to go over everything. All right, so we get 3 rows affected. Let's do a select title from books. Just make sure that we have those in there. Here we go. We had up to Consider the Lobster in the last section. Now we have 10% Happier, Fake Book, and Lincoln in the Bardo. All right, so that's all I wanted to do here. I highly recommend that you go and do this if you want to follow along. It will make the exercises much easier. Well, it will make them possible in the first place. And you'll be able to type the code that I type on your own. So I highly recommend that you do it, but I guess you could just watch if you wanted to. So without further ado, let's get on to the new stuff. Now then, I don't really like now then. I use all right too much. Okay, how about up next, we're going to talk about distinct. So distinct is something that we use in conjunction with select. So when we're selecting data out, let's say we're doing something like give me all book titles from the database. And we may have duplicates in there, and we would get all those duplicates because we just asked for all titles. But if I say give me all distinct titles, it will do what that sounds like. It will only give us the distinct or unique titles. So without further ado, let's take a look at it in use. So here's an example. The first thing that you should notice is that distinct comes right after select. So we're saying select author last name. So there's a bunch of authors, and in our table, some books have, or some authors have multiple books. So David Foster Wallace, for example, has 2 books in there. So when we say select author last name, we get 2 results. We get David Foster Wallace, and then again, or if we're only doing last name, we get Foster Wallace and Foster Wallace. So if I wanted to know only the unique or the distinct author last names in my books table, I would write this query here. Select, and the only thing that's different is the distinct. So select distinct author name from books. So let's try it out. We'll go over here, make some space, and let's just start, just to show you what I'm talking about, by select author without the distinct from books. just like that. And as you can see, we have Gaiman, who's in here twice. Eggers is in there twice. Carver is in there twice. Foster Wallace is in there twice. And Harris is in there twice. However, there's something kind of weird about Harris that we'll take a look at in just a moment. So if we only want to just get a survey of all the authors in our database, but we don't want duplicates, it's as simple as select distinct author lname from books. Just like that, hit enter. Now it's much shorter because those duplicates are gone. So now we only have one Gaiman, one Eggers, one Foster Wallace, and one Harris. And of course we could do that for other things. So let's try it for years. So we have select released year from books. You can see, let's see, are there some books that have duplicates? So for example, 2003, there's two 2003s at least. I think there's multiple, at least one more when I designed this or when I created the data. But let's just focus on 2003. So there's two of them there. So if we do a select distinct released year from books, our list is shorter. And now we only have one 2003. So the reason I show it to you is not just to show you another way of, or another example, but also we're working with numbers here. And that's important to remember that released year is an int. It's not a varchar, but distinct still works. There's one more advanced thing that I want to talk about here, which has to do with when we did our select. Let's start again with author lname from books. When we did this, remember that and actually let's do author fname and lname. So when we did this, remember we have Neil Gaiman twice and Dave Eggers and so on, but then there was Dan Harris and Frida Harris, two different people, two different authors with the same last name, which is a pretty common situation. So when I do distinct, select distinct author lname from books, it reduces them, to just the distinct last name, which is what you would expect. It only gives us Harris once, which makes sense. We're asking for distinct author last names. But what about distinct full names? What if I want every distinct author's full name printed out? So basically, what if I just want to know how many distinct authors there are? Not just based off of last names or just first names, but both need to be distinct so that, Dan Harris is distinct from Frida Harris. There are a couple ways of doing it. One, you already know at this point. You can use concat. So I'll show you that now. What we could do is concat author fname and author lname, and then ask or select distinct versions of those. So if I make a new file, this one won't be too long, but I'll make a new directory first, and I'll just call it refining selections. You don't have to do this, but I'm getting a little messy in here, so I want to make a new file in that directory, and I'll just call it distinct.sql, the most important part. Okay, so in here, right now we have our select distinct author lname from books. So let's start off by just running this, make sure that our file is working. One thing I will point out, I don't recommend putting spaces in your directory names. It's just not a great idea. So I'm going to edit that. It won't break anything. We can still do it, but it's just not great. So let's just do like that. Refining elections, well, that might work too, but refining selections. Alrighty, so if we want to run it, it's a source refining underscore selections / distinct.sql semicolon, and it works. Okay, so back to the problem at hand. How do we actually get just distinct authors, first name and last name? So what we could do, I'll comment this out for now, is a select, and then we can concat author first name and author last name, just like that, from books. And if we save and run that now, we get this. And if we try and do distinct on that whole thing, that works. We get Dan Harris and Frida Harris are distinct. And we only have one Neil Gaiman, one Dave Eggers, and so on. And of course, we could go add the space that we want there and try doing it again. And that gives us distinct full names like this. That's one way, but there's actually an easier way. And that's using distinct. We just do a select distinct. And if you do author, we can do F name first or L name. Just separate them by a comma. And we try running that now. You see, we only get unique rows back. So it's basically applying distinct to the entire row. So in this case, it's basically saying I want the combination of the first name and last name to be distinct. So that's why we end up with one Neil Gaiman, one Dave Eggers, and one Dan Harris, and one Frida Harris. So it works in that way. The only difference here, aside from this being longer, is that here we're actually just combining them and checking if it's distinct. Here, MySQL is doing that for us. And it depends just how you want your results printed out. If you want them combined as a full name, then this method works better. And if you just want to keep your data separate in 2 different columns, then this is much easier and a little bit shorter. All right, so that's pretty much all there is to distinct. At its core, it's pretty simple, and it's powerful too. It's something we'll use quite a bit throughout the course. As our data gets more complicated, we'll also have more duplicated data, which isn't a bad thing. But sometimes when you're trying to understand it or work with it, you only want distinct data. So you use distinct. All right, I should shut up. Moving on along to our next topic. I guess that's okay, moving on along. I'll keep using that. Our next topic here is order by. So as the subtitle tells you, it's how we can sort our results, which is something that we'll want to do. Hopefully you see why that's useful when you're trying to understand things. It's good to be able to sort your data. So with our books, for instance, right now we're getting them all in the order that they were inserted in. And maybe we want to do things like find the best-selling books or the worst-selling books, or find the most active users on our website or the least active users, or something similar. Find the most upvoted posts or the post that has the most comments on our blog, or whatever we're working with. It's important to be able to sort things. And again, the way we do that is by using order by. So let's take a look at an example. Here's a query that's going to select all the author last names from books. So up until this point, nothing is new. Select author last name from book or books. But after that, we add on this little thing, order space by. That's something that trips me up, by the way, that there is a space. Sometimes it feels like it should be one word or there should be an underscore, but there's a space. Order space by. And then what do we want to order it by? By the last name. So let me show you. If we go here, we just do a select author L name from books. This should be review. What we get them in the order they were inserted. So that's not alphabetical at all. So if we want to do alphabetical, select author L name from books, order by, and then we have to say author L name, just like that. And as you can see now, we have Carver up top, all the way down to Steinbeck. And you should notice it is sorted by default in ascending order. So from C or A, technically down to Z. And it's actually alphanumeric as well. So if we do titles, for instance, let's just do select title from books. We've got a title that has an A at the beginning, but we also have 10% happier. So if we do this, select title from books, order by title, you'll see we get the 10% happier first before the A's and all the way down to W. So as I mentioned, it is ascending by default. So if you don't specify an order, it just assumes you want ascending. But of course we can change that, as my slide says, by just providing one thing at the end. So everything up until this point is the same. Select author L name from books, order by author L name, space, DESC. And in my opinion, this is also something that's kind of confusing because it's DESC, but then the abbreviation for ascending is ASC, which is only 3 letters versus 4, but that's just my opinion. So let's try it now. If we recall what we had, select author L name from books, order by author L name. There we go. This is the original in default ascending order. But if we add DESC, you can see it's reversed. Now it goes from Steinbeck down to Carver. Or if we do the same thing with our title, and we just add on DESC, it now goes from white noise down to 10% happier. And of course, order by will also work with numbers. So it's pretty common that we want to sort things numerically, whether it's, the number of orders or sort the highest priced items, or like I said earlier, sort the blog posts by whichever have the most comments, most to least, or something like that. Those are numeric values. So to do that, it's the exact same syntax. All that we change is what we're ordering by. So in this case, released year, which is released year, which is an integer. Select release year from books, order by release year. So let's try it out. Let's do a select release year from books without the order by. And they're in all sorts of crazy order. I think our lowest one is 1945 all the way up to 2017, which is that Lincoln in the Bardo book. Definitely recommend it still. So if we recall that line and just add on order by released year, there we go. And by default, it's also ascending, 1945 up to 2017. We could reverse it with DESC, just like that. And just to prove to you, you can do this. You can be explicit with ASC, ascending, and get the same order if you left it off. And not to harp on this too much, but I don't like that this is 4 letters versus 3 letters. It should be consistent. So if we leave it off, though, we get the same results. Okay, so that's the basics of order by. Another thing I'd like to highlight here is that we've been doing things like select released year, order by released year, where it's matched. What we're selecting is matching how we're ordering it. You don't have to do that. So let's say we wanted to get, let's say we want title and year, released year, that is, and pages, why not? And I want all 3 of those from books, order by, and we'll do released year. So I can do that, and it's going to order them by the release year, but still gives me all the data. So it's not like, it has to match. Or I could even leave released year out of this entirely. I don't have to select it, but I can still order by. So I could select title and pages and order by the released year. You can see the first one we get is Cannery Row, and the first one we got here is Cannery Row from 1945. And the last one was Lincoln in the Bardo, 2017. Last one is Lincoln in the Bardo, 2017, even though we don't have the year actually printing out. So that's all I want to show there, that you don't have to be ordering by something that you're selecting, or that it doesn't have to be the only thing that you're selecting. So here's another little quirk of order by. If you take a look at this query, select title, author F name, author L name, and I put this on 2 lines here, not because it's correct to do that, but just so that it's easier to read for you. So select title, author F name, and author L name from books, order by 2. What do you think the 2 refers to? Well, in this case, it's actually just a shortcut. So we don't have to rewrite author F name. So if we're selecting title, author F name, and author L name, this will be 1, this is 2, and this is 3. And it's a shortcut for me to say order by 2, author F name. So let's copy it over, try running it. And you can see the results we get back. They're not sorted alphabetically here, even though it sort of looks like it because we have 10% happier and then a hologram for the king, 10 and then A, but it's not. The rest of the way is not. But you can see over here, we've got Dan first, and then David, Dave, Data, Don, Frida, blah, 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 down to Raymond. And if we wanted to sort instead by last name, we just change it to 3, again, because author L name is the 3rd thing that we're selecting. And now we go from Carver down to Steinbeck. And likewise, we could change it to 1 to sort by title. And we could also switch it over to descending, and that works. And if we did switch the order here, just to show the order does matter, so if I do author L name, comma title. If I want to sort by title, I would need to do 2 now. And now they're sorted by title. Okay, so there's one last thing, and I made a slide to remind myself about it, which is this here. So what we can actually do is sort by or order by 2 different columns, which seems like something that you wouldn't really do that often, and truth be told, it's not, but I just want you to know that you can. So to show you what I'm talking about, let me first do a select, and I'll make a new file for this one as well, just because we're going to have a little bit of code. Let's do new file. I'll just call it order_by.sql. Okay, and if we do a select author F name, comma author L name from books, just like that, save it, and we need to do our source order by.sql, just like that. And I forgot the directory, refining selections /. Okay, so when I do that, we get first and last name, so not sorted. So now if I do an order by author last name, and I redo it, everything looks good. We have our authors sorted alphabetically, Carver, Gaiman, Harris, but then that's where we run into our problem, which is Harris. And it's not really a problem, but if we wanted our authors sorted alphabetically, technically when there's 2 authors that have the same last name, and we want the entire author name to be sorted alphabetically, well, then we need to go to the first name. And in this case, Frida Harris is in front of Dan Harris, even though D comes before F. So we want Dan to come before Frida. And that's where this comes in handy. We can sort after we sort by last name, then sort by first name. So it's not going to redo everything. It's going to keep basically the initial sort, and then sort first name if there's any conflicts. So we can just add that in as a comma, author, F name, and save. Now, if you just focus here, so we have Frida Harris and then Dan Harris. And if I source that and run it, you can see it just switched. So everything else is the same. Carver first, Steinbeck last. But now Dan Harris comes before Frida Harris. All right, so that's actually it to order by. I saw a lot there. It's a little bit dense. I apologize. But order by is useful. Like I said, you'll be sorting lots of things, and it helps you understand your data, especially when we're talking about sales data or site-specific data. There's a lot of insights that you can get just by putting it in an order. Next up in our toolbox is limit. So limit allows us to specify a number for how many results that we want to select. So I could say things like, I want the first 2 best-selling books rather than all best-selling books, or the top 10 most recent books. So we often use it in conjunction with order by or sorting, because that typically is going to give you something meaningful rather than just saying, select all books and give me the first 2. Well, how is first defined? And we can do that. I'll show you that. If we do a select, let's just do title from books. The order that we get them right now, again, is the order they were added. So we have the namesake, Norse mythology, American gods, and so on. So I could limit this. And the syntax looks like this. I just add limit at the end, just like we added order by. Limit, let's say 3. And now I just get those first 3. So it's going to limit it to the first 3, whether they're sorted or not. It doesn't care. It just chops it off right there. So again, it's not that useful or that meaningful just to do it on its own like this. But we could do, limit 1, limit 10, and so on. And that's basically all that there is to limit. We can do it with a select star. If I only want, let's say I want everything about the first book. There we go. I get the namesake, and there's everything about it. But more often than not, we're using it with order by. So here's an example. If I want the 5 most recently released books, I'm going to, and I only want the title and the release year in this case. So select title and release year from books. Then I'm going to order them by the release year, descending, and then I'm going to limit it to the first 5. So let's try it. I'll go ahead and make a new file again, limit.sql, and in there, I'll write a select title, comma, released year from books. I won't add limit yet. Let's just make sure our source is working. So we'll do a source, refining, why did I name this so long? Refining selections / limit.sql. Fortunately, I only have to type it once. Okay, so that's working. So now what we'll do is order them by that released year. So we'll do an order by, and we could write release year, and I will because it's more specific, or it's easier to understand. It's more semantic to write it out, even though it's longer. But of course, we could replace it with 2, as we just saw in the last video. So order by that release year. If I do that now, that gives us all the books ordered in ascending order based off of their year, which is not what we want. So we can switch that with DESC. There we go. And now I can limit it to 5. And so that limit comes last as well. So it's going to do everything and then chop it wherever you specify. So that's important to know. So let's try it now. Make sure I save. And there we go, the 5 most recent books. And of course, we can change this to whatever number you want. If you want the 1 most recent book, or if we wanted, let's say 14, we can do that. So there are a few other ways we can use it. For example, here's the same query. However, I've written it slightly different. So everything up until this point, right here, is the same. Limit. But this time I'm saying limit 0, 5. So if we just copy this, I won't make you watch me type that whole thing out. And I comment this out. And I try running this now. Just take a guess. What do you think will happen? And here we go. It does the exact same thing. So this is a syntax that allows us to specify a starting point and then how many we want to go from there. So basically it's saying, and this is kind of confusing because it starts at 0. So the first row in a table is the 0th row. But then when we're dealing with strings, like when we had hello world, H is actually the first character in MySQL at least. So anyways, it's saying I want the first row and I want to go for 5 rows. So we could change that. I only want 3 rows this time. If we rerun it, it gives us the first 3 rows. But then I could shift it. Let's say I want to go, I don't know why, but the second row onwards. So it gives us Norse mythology, 10% happier, and the circle. If you didn't catch that before, when it was 0, we got Lincoln and the Bardo, Norse mythology, and 10% happier. When I change this to 1, it shifts the starting point. So it's not that, it's not common at all, but you could do things like 10, 1. And what this will do is go to the 11th book. Well, I need to save first. Now if I run it, it will give us the 11th book. And just to make sure that we're right there, if we rerun it now, we could count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we get fake book. So if you need to access very particular rows based off of order, that is a way that you can do it. It's just honestly not that common. Pretty much every time that I use limit, it's in a context like this. Limit 1 or the first 3 or the first 5 or something like that. But I'll give you a real reason you might use it. Let's say that you have a blog site that you've created and your blog has thousands of articles in it already. When a user visits the blog page, you don't show them all 1,000, or let's say 10,000 results all at once for every blog post that you've written. That would be overwhelming, and there's too much information to display. Most likely what you'll do is have the first 10 posts, and then I can click a next button, and it will load from post 11 to 20. And I can keep clicking next, and so on. You've probably seen that before. It's called pagination. So you can do that by, rather than selecting everything from your database, you could select from 0, and I only want the first 10. And then the next time through, you could select from 10, and I want 10 more, and so on. So that is a situation where you could use that limit and provide a range like that. But again, most of the time, I just use this, limit and then one number. The very last thing I'll show you is that this is actually straight from the docs from MySQL. I think it's really clunky and weird that they even specify this. If you wanted to select from one row all the way to the end of the table, so I want from row 5 all the way to the end, we might have however many thousand rows. There isn't a nice, elegant way of doing it. This is what you have to do. Select star for whatever you're selecting from whatever table, limit, and then where you want to start, comma, some gigantic number. And I'm not kidding you, I actually have it in the docs here. Right, where is that? Right here. To retrieve all rows from a certain offset up to the end of the result set, you can use some large number for the second parameter. So that's their official suggestion on how to do it. Select star from table, limit 95, comma, some gigantic number that you would know you never have that many rows in your table. So we could actually do that here. If we just do a select title from books, order by, and let's just say I want to go, we don't even need the order by, honestly. Let's just do a limit. And if we just do limit 5, that's going to give us the first 5. But if I want to go from 5 to the end, I can do limit 5 and then some gigantic number. And in our case, it doesn't even have to be that gigantic because we don't have that many books. But if I do that, it gives us everything after 5, or technically 6 because it starts at 0. So I could reduce this down. I could just do like 50. And it gives us the same thing because we don't have 50 books. So it just goes until the end. So that's it to limit. With all those weird things that I showcased and the odd situations and ways you can use it, the most common and the way that almost always that I use it is this. Just limit and then a single number. Alrighty, so that's it. Moving on to one more and then we're done. For this section at least. We're not done with the whole course. Alright, so we have one more video here, or at least one more tool for the toolbox before we get to the exercise at the end of this section. And that tool is something called like. And I'll start off by saying like is very useful. It basically allows us to perform better searching of our data. So if you think of when we saw how to use where would allow us to find exact matches. So I could do things like select star from books where title is exactly Harry Potter and the Sorcerer's Stone. But what if I wanted to select all Harry Potter books? I would want to do something like select star from books where title contains Harry Potter or starts with Harry Potter or something like that. And we don't have a way of doing that yet until now with like. So like allows us to do things like this. Imagine someone comes into your bookstore, if we have a bookshop, and they say, there's a book I'm looking for, but I can't remember the title. I think the author's first name is David, or maybe it's Dan or Dave. And you could go over to your system as a really helpful bookstore employee, and you could just search for, let's say, books written by authors whose first name starts with DA, which I guess is a very broad category, but you could still do that. If you searched for authors at like a Barnes & Noble or a Popular Bookshop or Amazon, you can do that type of search, and it will work. It's just not that common. But we could do the same thing for books, like I said. Harry Potter is a good example where we want to search for all the Harry Potter books, not just the exact one word for word matched or character for character matched. So that's where comes in. Now, I'll warn you, it's going to look a little bit odd when I show it to you, but that's okay. It's not that complicated. There's just some weird symbols here. So here's an example of using like. Where, so this is ignoring the first part of the query, the select star from, or the update, or the delete, or whatever it is. So blank, where, author, F name, like, and then in quotes, I have this %, DA %. So I'll tell you first of all, what this is going to do is find where the author's first name has the letters DA in it. And these little things here, those percentage symbols, kind of like that animation there, those are known as wildcards. So that's basically the way that we specify we want to find author first names where there's something, anything at all. It's a wildcard. So any characters and then these two exact characters, DA, and then anything afterwards. So it's basically a way of saying whatever blank, anything, DA, and then whatever anything else afterwards. And if we try using this right now, actually, you'll see what happens. If we go over here and we do a select, and let's just do a title and author F name from books where, and then we'll do author F name like, and then this is where we need those wildcard symbols, and we'll put DA in between. So once again, this is saying anything followed by DA, exactly DA. So it can't be D and then S and then A. It has to be DA and then anything afterwards. So if I hit enter now, you'll see that it works. We get these authors, Dave, David, Dan, and Frida. And you might notice, well, Frida, that doesn't start with DA, and you would be right. It ends with DA, but it still meets this query's it still meets the conditions for this query, which is anything, DA, anything. So in this case, it's FREID, or FREI is meeting this, and then we have DA, and then this wildcard, there's nothing afterwards, and that's perfectly fine. This is not saying there has to be something after the D and the A or something before. As you can see, we're matching DA, VE, so there's nothing before it, that's fine, then DA, and then VE afterwards. So basically this is all about pattern matching. And if we wanted to refine this so that we only get author first names that start exactly with exactly with DA, we can do it like this. All we do is leave off that first wildcard, that first percentage sign. And that says, I want to find author first names where they start with DA and then anything afterwards. So it could be Dana, David, Dave, Dan, Darwin, whatever. So if we just make that one small change and we delete that percentage sign, you can see Frida is gone. I'm sorry, Frida, because Frida no longer fits the pattern that we're matching. Also, it's important to note that it is case insensitive, as you can see. This is lowercase d and a, and it still matches all these uppercase d's and lowercase a's. So if I wanted to do something slightly different, let's say search all books where the title has the word the somewhere in there. It's pretty simple. It's just a select title from books where title like. And if I just say the, that's only going to give me books where it's exactly the, and that's not what we want. So we want something followed by the, and if we just leave it like this, that's not going to give us anything because this is specifying we want books where the title has anything and then ends with the letters THE. That's not really what we want. So we'll add another wildcard at the end, and now that gives us all the books that have a title that has something, then THE, and then something else afterwards. So you can see we get the namesake, a hologram for the king, the circle, the amazing adventures of Cavalier and Clay, Consider the Lobster, and then Lincoln and the Bardo. Really good book, by the way. I know I've said that like 10 times. It's a good book. So that's the basics of using like. These percentage signs are very common. I know it looks kind of odd, but this is really, really important. Think of when you're searching, I don't know, if you use Reddit, if you're ever searching for things on Reddit, behind the scenes, like is being employed. Or if you're searching on whatever site you search on, there's some form or variation of this like going on, where your query, whatever you search for, it's not only matching exactly. So when I search for, on Amazon, I type in, let's just go with let's say Lord of the Rings. I search Lord of the Rings. It's not only going to give me books that have a title exactly of Lord of the Rings. It's going to give me books that have Lord of the Rings in the title somewhere. Obviously, their search is much, much more complicated, where it also searches things like, through comments and reviews and related books. And there's this whole complicated graph network of how the search works. But the core idea, the simplest search that you could implement, uses like. So that's the basics. But there's another wildcard character that I'll show you, which is the underscore. So here I have a really weird query. This is 4 underscores in a row. You'll just have to trust me that it's 4, and it was hard to tell. What this will do, so we're searching stock quantity, which is a number, and we're trying to find where it's like 4 underscores. And basically an underscore is a wildcard to specify exactly one character. Any character, but exactly one. So 4 of them in a row is saying, I want to find where the stock quantity is 4 characters long. So let me show you why we might want to do that. If I do a select stock, let's do title and stock quantity from books, just like that, you can see that we have stock quantity of 2 digits, 32, 43, 3 digits. Geez, it's giving me a tough time. Digits, 154. And then this great book, Linking in the Bardo, has 1,000 copies in stock. It's brand new. People don't know about it yet. They're not buying it. I'm sure people will buy it soon, though. Once, of course, they realize what a great book it is. So if I wanted to select books where stock quantity is 4 digits long, I could use that wildcard. So let me just show that again. So select title and stock quantity from books where stock quantity like, and all I have to do, so just to clarify, if I did this, that wildcard just means anything. So that's going to give us everything. And if I do 4 of them, it doesn't make a difference. That's not saying 4 characters. That's just 4 different ways of saying anything at all. It could be nothing. It could be 1,000 characters. It doesn't matter. So by adding underscores, that's 4 there, you'll see I get Lincoln in the Bardo. Or I could do 2 underscores, and I only get the 2-digit stock quantities. Now, that's not to say the only time you use underscores is when you're trying. Yes, Blue. It's my cat. Are you going to say hi? She's now sitting on the computer. Okay, so back to where I was. Get this cat hair out of here. The underscore is not only used, and actually it's not even primarily used for counting digits like that, but it's a way of specifying exactly one character, like I said. Let's say that we're working with phone numbers, and in the US, they might look something like this. So we have an area code in parentheses, and then 3 digits dash 4 digits. And if we wanted to match that pattern, we would have something that looks like this, like, and we'd have our first parenthesis. And if we just put this wildcard there, that's going to say any number, any letters, whatever it is, in between those parentheses, but we're actually looking for 3 digits. And then another 3 digits after that parenthesis, then a dash, and then 4 digits. So basically, we have these 2 wildcards at the end of the day. %, which means anything or nothing, and then underscore, which is exactly one thing. And you can chain them together to match patterns. Then that brings up another question, which is, but what if I'm searching for a book that has a % in it? How would I do that? And you may have noticed that I expertly planted a book title with a % in it. I was thinking ahead for once. How would we select that? Or there's also a book title that's not so creative that has an underscore in it. How would I select that one? If these characters are special wildcard characters, how do I actually search for the exact character %, or the exact character underscore? And the answer is actually pretty straightforward. We use what's known as an escape character. In this case, I always forget which one's backwards and forward slash, but whichever slash this is, the one over the enter key, I'm pretty sure that is backslash. So backslash % is going to match a %. So this entire thing right here is basically saying %. Likewise with underscore, it's backslash underscore is the escape character. So let's put that into practice. Let's try it out. So we'll select title from books, and we'll just do that first of all, and you'll see we've got 10% happier and then fake underscore book. So let's start with 10% happier. So I want to select title from books where title like, and just, I mean, this should be clear by now, but if we tried to do this, that's not going to work. That's going to give us everything. But if I tried to say, okay, %, that means anything, and then a percent sign, and then anything afterwards, that's not going to work either, because that's basically just 3 different ways of saying anything at all in the title. So that's where we need our backslash. And now what you could read this as, you could condense this to say exactly a percent sign, 1 percentage sign, anything before, anything after. And there we go. That's how we get 10% happier. Same thing with the underscore. I won't go through that whole routine again. We just replace that backslash percent with backslash underscore, and that gives us fake book. All right. So that's all that there is to like for now. It's very, very useful. We'll be using it quite a bit in this course. It's probably one of the most commonly used things in MySQL or in SQL when doing queries. In all likelihood, you won't be matching percent signs or underscores all that often, but you'll be doing things like this all the time, where you're using the percent wildcard and the underscore wildcard to match patterns. Okay, next up, exercises. Okie dokie, artichoke. Yep, that's how I'm starting this video off. It's your turn. So we've covered 4 different things here, 4 new tools for this mysterious magical toolbox. We've got distinct, as well as order by, and then limit, and then finally like. And you're going to put those to use along with some of the stuff you've learned up until this point with a couple of exercises. And there are some clown emojis here to show you how excited you should be, and they're not at all creepy. So here's the first thing I need you to do, or I'd like you to do. Please do it. Select all story collections. So some of these books have titles that contain the word stories, which tells you that they're a collection of stories. What we talk about when we talk about love, stories. Really good read, by the way. Where I'm calling from, selected stories, oblivion, stories. So using what we just saw, and that's something I just want to point out, for all of these exercises, there are ways that you could directly select things maybe a little bit easier, or you could cheat in a way, but make sure that you do it the way that I specify, please, using the things you just learned. So specifically, titles that contain the word stories. Not exactly stories, but something that contains stories in it. So that's the first one. All right, and then the next one, find the longest book in the entire database or in the entire books table. So this is what you should get back. Print out the title and the pages. The Amazing Adventures of Cavalier and Clay is 634 pages. Of course, don't just select based off of where pages is exactly 634 or where the title is The Amazing Adventures of Cavalier and Clay. Please do it the right way so that your query would always work no matter how many books are in the table and what they're named and how many pages they have. It will always get the longest book. Okay, just one. Then the next problem, print a summary. In our case, a summary contains the title, dash, the year. And print only three of the most recent books. So 2017, 2016, and 2014. So again, a summary. And it says up here, it says summary, so that remember how to do that. The title, dash, the year it was released, and then only print out the 3 most recently released books. All right, next up is find all the books whose author's last name contains a space character. And it's only David Foster Wallace in our case. Don't cheat and just say where author L name is exactly Foster space Wallace. But how can you find any author last name that has a space in it? And then once you do that, find the 3 books with the lowest number in stock, the lowest stock quantity. So as you can see here, we've got American Gods has 12, Where I'm Calling From has 12, What We Talk About When We Talk About Love has 23. And I'd like you to print the title, the released year, and the stock quantity. So just to reiterate, the 3 lowest stocks. All right. Then we have this one. Print the title and the author last name. So we've got title, author L name, sorted by the author's last name. So this is all of the books, by the way. So sort by the author last name and then sort by title. Because some of these authors, for example, Carver or Eggers or Gaiman, have multiple books. So if we look at Carver, for instance, Carver has What We Talk About, blah, 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 Where I'm Calling From. What we talk about comes before Where I'm Calling From, alphabetically, if that makes sense. Same thing with Eggers. a heartbreaking, a hologram, the circle. So sort first by the last name of the author, and then on top of that, the title. Then we've got this one, just make this happen. It's kind of difficult to write out exactly what's happening. The main idea is that we're going to go through every book. You're going to print out this string here. My favorite author is, and this is yelling in all caps, I won't wake my neighbors, it's kind of late. But my favorite author is, and then the author's first name capitalized, and the author's last name capitalized, and an exclamation point at the end. And do that for every book, sorted alphabetically by the author's last name. So you can see Carver comes first, Eggers, Foster Wallace, Gaiman, down to Steinbeck. And then make sure you call it Yell up here. Yes, it's a bit of a complicated one, but fortunately it's last. Hopefully you can make this one work. It's a little bit long. Good luck. See you in the solution video. All right. So hopefully you made it through those exercises, or maybe you're just wanting to watch the solutions, or maybe you're here accidentally. However you got here, what I'm going to do in this video is go over the solutions to the previous video. And that's a bad noise. Why'd that happen? All right. So the first one, select all story collections. So those are titles that contain the word stories in them somewhere. And we just want to print the title. So I'm going to go over here and make some space. And the first thing that I'll do is just make a new file, and I'll just call it exercises.sql. And then I'll open that up. And we'll start off with this first one. Select title from books. And we'll start there. Just make sure we're doing everything correctly. Source, refining, selections, / exercises.sql. Make sure that, okay, it's working, selecting the titles. So now we only want the ones that contain stories. So that's going to be a where, and we're going to do title, like. And this is, if we just do stories, it's not going to work. That gives us exactly stories. We're going to want that wildcard character, just like that. And now we get what we're looking for. Technically, with our specific data, we could leave that last percentage sign off, that last wildcard, because all of the books that contain the word stories, it comes at the end. But that may not always be the case. There might be a book out there called My Favorite Stories for Kids, or something like that. And if we wanted this truly to just find all books that have stories in the title, we need both of those wildcard characters. All right, so that's the first one. Next up, find the longest book. So print out the title and the page count for the one longest book. So we'll go ahead and comment this line out. And let's just do a select title and pages from books, just like that to start. Okay. So now what we want to do is sort them. We'll sort them by the pages. So that's an order by pages. And if we just do the default sort, remember that we get ascending rather than descending, which is what we want. What we're going to do is use limit to give us the first result. But right now, if we do limit 1, it's going to give us the shortest book rather than the longest one. So we want to reverse that sort with the descending order. So now the first one is the longest. And then we just add our limit 1. And we run it again and again and again. And it always works. And so whatever book has the longest page count will always be what is printed out here. All right. So that's that one. Let's comment it out and move on. Print out a summary containing the title and year for the 3 most recent books. So this one required you to not only use order by and limit. We're ordering by most recent year and then limiting to 3. But you also needed to use concatenate to concatenate the title with a dash with a year. So let's do that now. Let's just start by doing the select concat, and it was title, comma, and then we have a space and a dash and a space, comma, released year. And we'll start with just that from books. Save. Okay. Oh, the other thing we wanted to do is clean this up so it says summary up there. So this is also review. we'll say as summary. Okay, so now we get that. Now we want to order them by most recent. And let's break this up onto some different lines here. From books, order by, and we'll order by released year. And if we try that now, we also see that it does work, but it's in the opposite order that we want. We want most recent, so we need to reverse that again with descending. And then finally, we want to limit it to the first 3. Limit 3. Or if you want to get fancy, we could do this, but I don't like doing that. So that's much easier. Okay, so that gives us Lincoln in the Bardo - 2017, Norse Mythology - 2016, 10% Happier - 2014, summary. That's all good to go. Next up, find all the books that have an author last name containing a space. And don't cheat by just doing Foster Wallace. So let's comment this out first. And this one's actually pretty short and easy. It's just a select, and we're looking for title and author L name. Select title, comma, author L name, where author L name, like, and of course we can't just say space because that's only going to find authors whose last name is exactly space. And it looks like, oh, I'm forgetting from books. Hopefully you caught that before I did. But back to what I was saying, this isn't going to work because we don't have any authors whose last name is space. So what we want is that wild card on either side. Anything with a space and then anything afterwards. Now we get Foster Wallace. And that's it for that one. Next up, find the 3 books with the lowest stock. So we want the title, the release year, and the stock quantity. 3 books with the lowest stock. So let's start with commenting this out, just like we've done with all the others. Select title. What else was it? Release year and stock quantity. Okay. Just like that. And we'll have our from books. We'll start there, make sure that works. Okay, so now what we want to do is sort them by stock quantity. So that's just an order by stock quantity. And you can see that gives us the order we want. We want them to be in ascending order this time rather than descending because we're looking for the lowest stock quantity, 12 all the way up to 1,000. Okay, and then we want to limit it to 3. I don't know why I picked 3 so many times in these exercises. Let's try it now with that limit 3. And there we go. American Gods, where I'm calling from, what we talk about when we talk about love. That's what we're looking for. Then we've got this one. Print the title and author last name sorted first by author last name and then by title. So let's get the title and author last name to print first. Select title, comma, author L name from books, just like that. And at this point, we all know what that does. So now let's sort by the author last name. So that's just a simple order by author L name. And that gives us the alphabetical order we're looking for. So we don't need to use descending. That's all right. But then if you look over here, if we take Carver's books, notice that where I'm calling from comes before what we talk about when we talk about love, even though WHA comes before WHE. So we want to now sort by title there. And the way we do that is not by just changing that to be title, because then it purely sorts by title and ignores author L name. Rather, we want to do this, author L name, comma, title. And there we go. Now you could also replace this whole thing with 2, 1, which I really don't like, just because it's not very semantic. It's not meaningful to look at this, but it is shorter. And again, that 2 is referring to author L name and 1 is referring to title. It's just the order that we're selecting them in. So I'm going to change it back, but I will also duplicate that below and change it to 2, 1, and comment that out as well, just so we have both solutions. Which brings us to the last problem. Hopefully it's the last. Okay, it is. Make this happen. So we want to yell, my favorite author is, and then the uppercase first name of an author, and then a space, and the uppercase last name of an author, and then exclamation point. Yeah, it's kind of a lot. Okay, so let's start with selecting, and we know already that, well, we can start with select from books, sure. What we're going to want to do is concatenate, my favorite author is, and then an uppercase version of Raymond and a space, and then uppercase version of the last name. So, and an exclamation point. It's a lot of concatenation. So we're going to have a concat, and I'll just do this. Well, let's do it this way, just like that. What are we concatenating? Well, let's start without the uppercase, or without. So let's just start with my favorite author is, and we'll add a space, comma, and then we want author, F name, and then we want another space, this space here, so they don't just run together, comma, author, L name, finally, an exclamation point. It's a lot. So let me drag this down a bit so we can see the whole query. Select the concatenation of my favorite author is, space, the first name of an author, space, the last name of an author, exclamation point. Let's save it and run it. It's pretty long. Oh, and this is partially messed up because you can see up here, the column heading here is this entire thing. So let's add the as yell. And now if I run it, there we go. Okay, so we're close. The next thing we need to do is capitalize author F name and author last name, which is easy. It's just an upper, like that. Save, rerun it. Okay, it's all uppercase now. We have one last thing, which is sorting alphabetically by the last name. So from books, order by author, L name. Long query here. Let's try it. It looks like it worked. We got Raymond Carver all the way down to my favorite author is John Steinbeck. And that's about as loud as I'll yell in here. Don't want to wake my neighbors. All right. So congratulations. Hopefully you made it through this relatively unharmed. It's a lot of exercises, a lot of ordering by and limiting. But the reality is you'll use those a lot. It is very useful to be able to determine, the highest page count, maybe not, but the best selling book once we get to sales and users and stuff, for the most active users, or like I keep coming back to the highest commented post, or the most trafficked, the most clicked on ad. All those sorts of bits of data are really useful, and you'll use order by and limit all the time, as well as other tools that we saw distinct and like. They're all very useful. All right. Well, I recommend you take a quick little break, and then we'll move on. Hey, welcome to the next section. So this section, as you can probably gather, we're still working with our books data. I hope you're not tired of it yet. If you are, we're almost done, but it's important that we keep working with one data set for a little bit at least, so that you can get familiar with it. And the reason that matters is that as we do some of the more advanced things, we want you to be able to check your work. So in this section, we're going to learn a lot about different ways of performing analysis on data. So things like finding averages or summing a bunch of data together, grouping things by authors and calculating average quantities or page numbers per author. These are operations that if we had 10,000 books or 10,000 something else, it's really hard to know if you're doing it right or wrong. You get an answer, just a number, let's say 67.5, and how could you know if that's right or wrong? But if we're working with books and we have 20 of them, and you're familiar with the page counts and the authors, you'll know, okay, this author has 3 books, that seems right, versus, okay, that author only has 2 books, why are we saying that, we have 3, or something like that. Terrible example, but the same idea is true. We know our data at this point. We're going to, at the end of this course, and along the way, we're going to keep upgrading our data to more complex structures, more tables, more rows, complex stuff. But at the very end, kind of the capstone case study, we'll be working with Instagram-esque data, fake data for Instagram, and we'll have thousands and thousands of rows. And you won't actually know if you're doing things right or wrong based off the number you're getting, unless you've manually checked your work by, doing 1,000 additions or something. So all that's to say, stick with the books if you can. And in this section, we're focusing a lot on these new aggregate functions. So those are things like finding averages, counting, summing things together based off of grouping data. So it's a bit hard to explain in a headshot without showing you code. So I'll let the code do that in just a few videos from now. But the rough idea is that we take our data and there's all sorts of insights we can gain. So rather than just working with an individual row or a group of rows, we can combine things into like mega rows. I can combine all of our authors and group books based off of who wrote them, or group books based off of what year they're written in, and then perform operations on those groups. So it allows me to do things like find the average sales that we've had per year. Or we could do things like find the average page number for books per genre. And then we could expand that obviously to more complex stuff. If you're working with advertising data, or let's say our Instagram data, we'll be able to, at the end of the course, do things like find out which one of our users is a power user or an influencer is what they're called, I guess, meaning that they have the most comments, the most likes on each one of their posts on average. So who in our database is getting on average the most likes and comments? Or we could do things like which hashtag generates the most traction. And to do that, we would need to analyze all of our hashtags and then take all of our photos that have those hashtags, group them together, figure out which one of those hashtags generates the most likes. So there's a lot of stuff that we can do with these aggregate functions. They form the backbone of a lot of the questions and analysis that we'll do throughout the course. All right, I'm rambling now. I'm going to go away. Hopefully you enjoy this section. It's important. I say that a lot, but it really is. And of course, we'll have a bunch of exercises throughout the course, or throughout the section, and especially at the end. And I'm trying to keep those interesting. Look forward to those. If you don't, just remember, it's a database course. I'm trying my best. It's databases. All right, I'm done. Alrighty then. Welcome back, everyone. In this section, we're kind of continuing with the trend of focusing on selecting our data, on reading it, if we're going back to CRUD. In the last section, we saw things like sorting with order by, using limit, and so on. In this section, we're going to focus on what are called aggregate functions. And basically, these are built-in functions in MySQL that will allow us to aggregate or combine data to get meaning out of it. So by the end, we'll be able to do things like find the average page length of all of our books, or find the average page length for each author. So, let's say we'd be able to tell that someone like Carver, who writes short stories, maybe has shorter books compared to David Foster Wallace. And that's just average, but we'll see how to do other things like count, sum, min, max, and a bunch of others. And they're known as aggregate functions because they work on aggregated data. So yeah, let's get started. It's time to learn some more stuff. And it will definitely 100% be the most fun thing that you've ever done. Let's get going. The first thing we're going to take a look at, the first one of these aggregate functions, is called count. And it does pretty much what you would expect, at least in the way that I'm going to show it to you now. We're going to revisit count in the next video once we introduce what's called group by, but for now we're just focusing on count on its own. And what it will do is count whatever you tell it to count. So here's an example. How many books are in our database? If we wanted to do that right now, you could do a select star from books and manually count, which technically that would work. But if we have, Amazon's database that has millions of books, that would be a lot of work. That would take at least a couple thousand Mechanical Turks to do. So that's not ideal. Instead, we can use count. And it just looks like this. Select count star from books. So let's try it, and then we'll discuss it a bit more. So here I am. I'm using the same database, just double checking, Bookshop. So we can do a select star from books. And like I said, we could go through and count. And you can't just rely on the IDs, of course, because we could have deleted some. So just the highest number of the ID is not a reliable way of knowing how many books are in there. Because when you delete something, those IDs don't change. They don't shift down. So instead, we do a select count, and we'll put star here, which basically will count every row, the entire row. So select count star from books, and we get 19. So that tells us there are 19 books. And we could verify that. Let me just speed this up as I count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so there were 19 books. So we can trust this count. It's right. And that's one way of using count, just to check how many things are in a table in general. A more specific way of using it would be to do something like this. How many author first names are in our database? And it's not 19, we know that now, because if we do a select author F name from books, we have some authors who are in here multiple times. Neil Gaiman is in there twice. So it's going to count them twice. It's just going to count everything here. So if we did this, select count author F name from books, is it really going to be correct? And the answer is no, as I just said, but let's just try it. Select the count of author L name from books. Or we're doing actually F name, aren't we? And it tells us there are 19 author F names. And that's technically true. There are 19 F names in here. I want to know how many unique first names are in there. And fortunately, there's a way of doing that. And it relies on distinct, which we've already seen. So we just put distinct inside of that count. So select count distinct author F name from books. Let's try it. Select count distinct author F name from books. And now it tells us 12. And I won't make you sit through me counting it, but there are indeed 12 first names that we have in our database. So instead of 19, it's now decided, okay, there's only one here, and there's one here, and there's one here. So that's the basics of using count, along with using count with distinct. Now I do want to show you a bit of an edge case here. Let's say I wanted to know how many unique authors are in my database. So that means first name and last name. So if we do our select count, and let's just do author last name first from books, we get 19. As you would expect, there's 19 rows. Every row has a last name. But we know that there are some duplicated last names. And if we just look at those, just do this very quickly, it's the same problem that we had with first name, right? We had Foster Wallace, we have Eggers, and we have Gaiman. So if we use that distinct, select count distinct last names, maybe you can see where I'm going here. If I hit enter, it tells us there's 11 distinct author last names, which is true. There are 11 distinct last names, but that doesn't mean there are 11 distinct authors. Because if we go and do a select author F name, comma, author L name, so if we look at both first name and last name from books, remember that we have Dan Harris and Frida Harris. So when we're selecting distinct last names, it treats this as the same because Harris is the same as Harris. So if we wanted to know how many distinct authors were in there, what we could do is do author L name, comma, author F name. And now it's only going to return distinct rows where first name and last name, or last name and first name, are distinct. And that gives us 12, which in our case is the same as just doing this right here, as we just saw, if we only do author F name. But that's because we don't have any duplicated names or any duplicated first names in there. We have David Foster Wallace, but we don't have, David Johnson or something. So this would be problematic if we had multiple Davids. So then we could use this where we're doing distinct author L name and author F name together. And the last thing we'll do is this question here. How many titles contain the string the, THE? So if you'd like to make this a little bit of a mini exercise, go ahead and try it. How many titles contain the in the title, or how many books title contains the? And the answer is that we need to use like alongside with count. So let's do it now. We're going to do a select, and let's just start by selecting the books, the title from books where title like, and then this is where we need those wildcards, THE, we need a wildcard on either side. All right, and here we go. We've got the namesake, the king, the circle, the amazing, the lobster, the bardo. Great book, by the way. So there are 6 of them here, right? Yes. So if we wanted to do that with our code dynamically, not by counting ourselves, we would just replace that with a count. Select count from books where title is like the, and it tells us there are 6. All right, so I just wanted to show you, you can combine it just like you can with any other of the things that we've seen. So, substring or concat or upper, they work the same way. In this case, we're just selecting count. All right, so that's count. Next up, we're going to go a little bit off the rails and talk about something called group by. Brace yourself. It's refreshing. Let's put it that way. Okay, so next up, we're talking about something called group by. And group by is going to be essential to everything we do in the rest of this section. And I'll warn you right now, take a deep breath, that it's a little bit weird. It's different than the things that we've seen so far. And in fact, for me personally, it's a challenging one to teach because, like I just said, it is different. It's not just a single little function that we can throw in there, like concat or upper, where we get a nice immediate impact, where we can see, okay, that was uppercased, or that was concatenated, or that's a count. Rather, we have to use it alongside some other functions. So it's going to take a little bit to explain, so hang in there and just know that we're going to get there. There is a payoff, and it is very useful. It's kind of the core of aggregating our data. It's how we can do things eventually, like average or sum, or find the minimum or the maximum, and so on. So here we go. This is a little blurb that I wrote about group by. Group by summarizes or aggregates identical data into single rows. So it's actually pretty self-explanatory, the name group by. We can say things like take all of our books and group them by the year they were released, or group them by the author last name, or take all of our T's, or actually let's say take all of the movies in our database and group them by genre. And that on its own is not that useful. But then we can say things like group them by genre and tell me how many each genre has, or group our T's by variety, like green tea, white tea, black tea, and so on. Group our T's by variety and find the average sales price for each one, for each variety, that is. Or add together all the sales for each variety and figure out which tea type is selling best. So we'll get there in time. But for now, let's start with a little example. Again, here's a reminder. Stay with me, please. Let's say we're working with a very small subset of our book data. So I just grabbed 5 books. So when we do select title and author L name from books, right now we'll get 19 in our actual database, but this is a fictional database where we get 5 books. We've got The Namesake by Jhumpa Lahiri, Norse Mythology by Neil Gaiman, American Gods by Neil Gaiman, Interpreter of Maladies by Jhumpa Lahiri, and A Hologram for the King by Dave Eggers. All right, so we get these 5 books out when we just select. Just like that. We don't do anything fancy. We're just getting title and author last name. So then we introduce group by. And we'll talk about the syntax in a little bit, but all that we've done, this is the exact same line as before. Select title and author last name from books. And we've added on at the end, group by author L name. And I've just done it on the second line just to make it so that this is all easier to read. Again, it doesn't matter. So group by author last name. And what we get looks like this, which is bizarre. It's probably not what you would expect. It's not what, to me, makes sense on a visual level at least. It does make sense once you learn what's happening, but on a visual level, it looks like basically it's only just giving us the unique authors, like Lahiri, Gaiman, and Eggers, and then just picking their first book title, right? So we're getting The Namesake for Lahiri, Norse Mythology for Gaiman, and A Hologram for the King for Eggers, but then we're missing these 2 books. And that is what's happening. That's what we're seeing here, which isn't really useful. Why would you want that? So what's actually happening is that even though it just prints out The Namesake by Lahiri, it's basically grouping based off of last name. And so it creates one big, let's call it a super row with all of Lahiri's information, or all the books written by Lahiri. So that's the namesake and interpreter of maladies. And it treats that as one row. And it does the same thing for Neil Gaiman. And then the same thing for Eggers, and there's only one Dave Eggers book in our data set. So even though this is all that we see, behind the scenes, they are grouped together in these super, mega, whatever we want to call them, rows. And that's important because the data is now grouped, and we can do things like this. Count how many books each author has written. So our query would look something like this. Select author last name, comma, we don't have to have this here either, but select the author last name, comma, count star from books grouped by author last name. So it's going to group them like we've already seen. And then when we do a count star, it's not going to count every row in our entire table. What it's counting is for each of these mega rows, how many sub rows are in there. So basically, how many things are under Lahiri? And in this case, there's 2. How many things, how many books are grouped under Gaiman? 2. And how many are under Eggers? 1. So then what we get spit out when we're actually selecting the author last name and the count is this. Lahiri, 2. Gaiman, 2. Eggers, 1. So we're only getting started here with group by. I'm going to now dive into Cloud9 and do some more. But just know that we will be using group by to do things like average. So once we have, let's say, grouped by authors, we could average the page count, like I said, or the average year that they wrote a book. Or we could find the first year they wrote a book using min, which we'll see in just a moment. Or we could sum the total page count, for instance, for every author. So group by is very important and versatile. For now, we're only using it in conjunction with count. So now let's dive into Cloud9 and do just that. So let's start with something simple like select title, comma, author, L name. Let's do actually first name and author last name from books. So no count or anything like that yet. So we have a much bigger data set, right? Let's do a group by now. Group by, and we'll do author last name. And we're going to just do the exact same thing. I want to know how many books each author has written. And we will run into problems, I'm just telling you now, with this Harris, right? Because we have 2 different Harrises, Frida Harris and Dan Harris. But when we group by last name, it just treats them as one. So it will say Harris has 2 books, which technically is true. The last name Harris has 2 books. Okay, so if we do this and just hit enter, it's not useful. I don't know why you would ever do that, honestly. It just is giving you sort of a preview of the mega rows, if you will. Basically, it's just taking the first book by Carver, the first book by Harris, but we don't see how they're actually grouped. So it's not that useful. It's not useful at all, honestly. So what we want to do is, rather than just title, author, first name, author, last name, let's do count star. And remember, count star in this case is referring to the grouped rows. So it's going to go to each of those grouped rows and count how many rows have been grouped together. Oh, and this is kind of a mess to look at, so let's actually get rid of title and just do author, first name, and last name. Now we can see. So Raymond Carver has 2. Don DeLillo has 1. Dave Eggers has 3. David Foster Wallace has 2. And then, as I mentioned, we have this problem with Harris because it says Dan Harris has 2, but that's not true. Dan Harris has 1 book. Frida Harris has 1 book. So to get around that, of course, we can do the same thing where rather than just doing group by author L name, hopefully you've seen that this is something that's kind of standardized across MySQL. We can do author F name as well. So it will group where both of these are unique. So then we do that, and everything else is the same. Raymond Carver has 2, Dave Eggers has 3, Foster Wallace has 2. But if we go down here, we now have Dan Harris with 1 and Frida Harris with 1. All right, so just to show you another thing that we could do, we could also group by released year. So, we could group by title, of course, but we don't have any books that have the same title. But we do have a couple books that have the same year. So let's say we wanted to get a nice printout that shows us in 2017, 1 book was released. In 2016, 2 books, or however many books were released. So we can do that pretty easily with just a select. And let's do released year, comma, count, star. So if we just do select released year from books, you can see, where's an example? I think 2003, we've got at least 2 2003s. And I know there's a couple more. I hope there's a couple more. So let's say we wanted to condense them all together and then put a count next to it as well. We would do that just like this. Select released year from books. We would group by released year. And rather than only selecting the released year, we also want to select count star. Let's hit enter. Now you can see we've got 1945, 1 book. 2001, there were actually 3 releases. 2003, there were 2 releases. So you can see that it's working. And if we want to get really fancy, go ahead, move on to the next video if you'd like. But I'm just going to show if we want to get fancy and print it out nicely, we can combine it with concatenation. We could do something like this. So rather than just selecting the count, we could do, let's see, a select concat, and we're going to concatenate the released year, comma. So let's add a string before. So I'd like it to say like in 2010, 2 books released. Or 1 book, I guess. In 2001, 3 books released. I actually want that string. So we can do in the released year, comma, the count, comma, books released. And technically, just to make sure, let's add a parentheses around the S because there's, in a lot of cases, 1 book released. So I don't want to say 1 books. Anyways, so let's make sure we have our correct parenthesis here. Select the concatenation of in the released year. We probably want a space there, don't we? This is where it gets kind of annoying that we're not using a separate file. So in 2001, let's say, space, 3, space, books, released. And then lastly, to clean this whole thing up, let's add an as, and we'll just call this as, let's just say year or something silly. We hit enter, and we get this nice little table. In 1945, 1 book released. In 2003, 2 books released. In 2001, 3 books released. Okay, so that's it for now, at least, with group by. We're going to be working with it in every video from here on out in this section. Like I said, we're going to move on to things like min and max, average, sum, fun things. Hopefully, sort of fun. Congratulations if you made it through this video. Like I said, it's a little bit weird. It's different than what we've done before. Hopefully it wasn't too boring. Okay, so next up, we're going to continue on with 2 new functions. And they go together, they fit well. They're min and max, minimum and maximum. And they do what they sound like, what their name says. They help you find and identify minimum values in a table or maximum values in a table. And we can use them on their own, and we can also combine them with group by to get further insights. So we're going to see how to do both. We're going to start off by using min and max without group by. So we can do things like find the minimum released year in our entire table. So, what was the first year any book was released? And to do that, it just looks like this. Select min released year in parentheses from books. So just like we did with count, where you could just count all the books if you wanted to, you can just use min on its own. So let me show you how to do that now. Go over to Cloud9, and we can just do a select min released year from books. And 1945 is the earliest book that we have released, or the earliest year that a book was released. We could also do something like select min pages if we want to see what's the shortest number of pages. And that's that. It tells us 176 is the shortest. So of course, maximum works the same way. So instead of min, we just type max, M-A-X, and it does the same thing. So here we're finding, well, it doesn't do the same thing. It works in the same way, but it does the exact opposite. It's going to tell us or return the longest or the highest number of pages. So if we do that, we'll just recall that last line and just change it to be max. 634. That is our longest book. And we could do the same thing with year if we wanted to. 2017 is our most recent year. It's the highest number year. So that's the very basics of max and min, or min and max, however you want to say it. I do want to call your attention to something sort of weird. What if I wanted to get the title of the longest book, not just the number of pages like we have here, just finding out that 634 is the longest. Isn't that useful? What if I wanted to know what is the book? What's the title? Who wrote it? The year it was released? Any other information? Well, you might think you could do this. Select max pages, comma title from books. And if we try it out, select max pages, comma title from books. It says that the namesake is our longest book, and it has 634 pages. And while yes, 634 is the maximum pages in our entire database, the namesake is not 634 pages. And in fact, if we just do a select, and let's just do title, comma pages from books, if we find the namesake, you'll see that it's 291 pages. And the one that is 634 is The Amazing Adventures of Cavalier and Clay. So that's a problem. Here's a nice little graphic I made. It's the largest emoji that I could make on these slides for some reason. So I'm just going to go ahead and insert a much larger one now. Post-production, very fancy. So how do we get around this? There has to be a way, and in fact, there's multiple ways. In the next video, it's a bit of a cliffhanger here. In the next video, we're going to see a couple options, including a preview of a more advanced method, something that we haven't seen just yet. But there is a way to do it using what we already know, something we learned a couple of videos ago. All right, next video. Okay, so what we're discussing in this video, in case you didn't see the last video that leads into this, is that there is a problem with trying to do something like this. Select max pages, comma title from books. If I want to find the title find the title of the longest book or any other information along with the maximum pages, it doesn't work. And what it's doing right now is actually returning, here we go, is first finding the longest pages, the maximum pages, which is indeed 634. But then when I ask for title, it's actually just giving me the first title, the namesake. And the reason that it does it, it's kind of complicated and weird, but basically you can think of it as SQL or MySQL is executing this, and it finds the max pages first, which is independent from this. So it finds this, 634, and there's only one row that it's preparing to print out. So then we get comma title, and there's only one spot to fill, so it just takes the first title. So these are independent of one another. They're not connected, unfortunately, but there are ways around it. So the first thing I'll show you is something a little weird. It's not weird overall, it's just weird to you at this point because we haven't seen this before. It involves something called a subquery, which we'll return to later on in the course, but I wanted to just preview now. And basically what it lets us do is run one query inside of another. So it looks like this. Select star, in this case I did star, although we could just do title, but select star from books where pages equals, and then this is the weird part, parentheses, and inside the parentheses we have another query. Select, in this case I did min pages from books. So what's going to happen is that this will actually execute first. Select whatever we have here. So let's say min pages, I believe is 129, or in our case, max pages would be 634. So it's going to find that and return 634 here. And then this will run select star from books where pages equals 634. So let's try it out now. And I'll show you basically manually what's happening. So think of it as doing a select max pages from books, just like this, which is 634. And then copy that and do a select. And let's do a, we'll do star, select star from books where pages equals 634. So it's a two-step process. And you can see, even though our formatting's a little screwed up, we get The Amazing Adventures of Cavalier and Clay, which is indeed the longest book, 634 pages. So we can do that all at once, or at least in one line of code with, if we just recall this, select max pages from books, that will be our sub query. And so that's kind of going to be a fill in the blank. So we'll have a select, and let's just do title and pages this time, from books where pages equals the result of finding the max pages. So it's doing what we just did, but in one line of code. And now you can see we get The Amazing Adventures of Cavalier and Clay, 634 pages. So we could also do that with min. And if we just replace this, you'll see that Raymond Carver's what we talk about when we talk about love, short story collection, great short story collection if you like short stories, is the shortest book, 176 pages. So that's all we'll talk about with subqueries, or that's all I'll show you. But as you can probably imagine, there are other uses for them. But there's a small problem. It's not really a problem, but there's something to consider, which is this is a little bit slow. In our case, it's not that slow. It's not slow at all because we have a very small data set, but it's effectively running two queries. So each one of these is run independently. So when we hit enter, when this executes, like I said, two things are happening, two separate queries that are going to take time, each one of them. Every time you do a select, it takes time. And there's a faster way if you are worried about speed, and it involves something we've already seen. So there's nothing new, no fanciness, no top secret, advanced features, subqueries, or anything like that you haven't been introduced to yet. There's a way of doing it using what you've already seen. So that way is using order by. So what we could do is just order by pages in ascending order. So do a select star from books, order it by pages ascending, and then just limit one. So chop everything else off and just take the first one. And that will give us the exact same result, but it's not going to take as much time. It's not going to be as difficult for MySQL to run because it's only selecting one thing and it's only running one query. So let's try that. We'll do a select, and let's just do title and pages from books. And instead of doing our where pages equals blah, 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 we'll just do our order by. And then we want to order by pages ascending, limit 1. And we get the exact same result that we got before with our longer query that involves a subquery. And we can do the same thing with min. And to do that, we just change our order. And yes, it still bothers me. 4 letters, DESC, but ascending is only 3 letters. So inconsistent. But if you remember that DESC for descending, you'll see that the longest book is, yet again, The Amazing Adventures of Cavalier and Clay. Okay, so that was a bit of a tangent, but it's important to address because I think a lot of people, myself included, I remember when I was learning this stuff, setting out and thinking that you could do something like select min, let's say year, comma title, comma, let's say stock quantity, and that it would go find the minimum year and then the corresponding title and stock quantity. And that's not the case. That's just not how it works, as we've seen. So I just wanted to point that out and highlight a couple of solutions, just so that you're aware going forward. Things aren't always as intuitive as you would hope. Okay, next up, we're going to continue with min and max and use them in conjunction with group by. All right, so I know you've been dying in suspense. waiting to see how you use min and max in conjunction with group by, well, it's finally time. So the way we do it is really similar. It's basically identical to how we did count when we used that along with group by. So let's take an example problem first. Something like this. Find the year that each author published their first book. So we want something like, I don't know, Raymond Carver and his, I don't actually know this, but let's say that in our database, his first book was published in sometime in the 80s, I believe, 1981, let's say. And we want to do the same thing for, let's say, David Foster Wallace, and his first book in our database was published in 1999 or whatever it is. Don't quote me, please. And so to do that, basically what we're doing is finding the minimum release year, but we can't just do this, right, where we do a select min release year from books, because that only gives us the absolute minimum. We want to group all of our books by author, so unique author, and then find the minimum release year for each one of those. So we need to use group by and min, and it looks like this. And yes, I know it looks kind of long, as this emoji tells you. It might be a little confusing. Basically, let's focus on the important parts first, which is this right here, and then the group by statement. Now remember, when we do group by, I'm doing author L name, comma, author F name, because we have two authors who have the same last name. And so I don't want, I believe it's Frida Harris and Dan Harris. I don't want their books grouped together. So we're separating it out. So this is going to group all of our authors together, make those different groups. I call them super rows or something like that. And then for each one of those, we're going to find the minimum release year, as well as the author first name and last name, because if we just find the minimum release year, it's not that helpful to see if that's all we print out. We want something like Raymond Carver, 1980, rather than just seeing 1980. So let's give it a shot. Make some space. We'll do a select author F name, comma, author L name, comma, min, released year. And then I'll do it on a separate line from books, group by, and we want to do that double author L name, comma, author F name. Let's hit enter. Here we go. So we got Raymond Carver, and the minimum released year for him is 1981, which I think is what I just said, or what I guessed. Let's say Dave Eggers, and we've got 2001, David Foster Wallace, 2004, Neil Gaiman, 2001, and so on. We can see the minimum released year for each author. And just to, hit this twice, that's annoying by doing it on separate lines. If I had left off, here, let me finish this, from books, group by, and let's just say author L name. If I just left it at that, everything looks the same except for our two Harrises. Dan Harris, 2014, Frida Harris, 2001. Well, now all we have is Dan Harris in 2001, which is not true. He never released a book in 2001. Frida Harris did, and that's because we're grouping everything by Harris. And so it puts Dan and Frida together. So that's why we need both. And so we're going to continue using that group by author L name, comma, author for F name quite a bit as we progress through these group bys in the next couple of videos. Okay, so we could also do something like find the longest page count for each author. It's very, very similar. We just need to use max. So that's going to be a select max pages from books, group by, and then our same author L name, comma, author F name, just like that. However, we just do that and it's not very useful. So let's go and add in select author F name, comma, author L name, comma, max pages. Now we can see Raymond Carver's longest book is 526. Neil Gaiman's is 465. John Steinbeck is 181. He only has one book in there, I believe. George Saunders is 367 is his longest pages. So that's the basics of min and max in conjunction with group by. Obviously, you could group things differently. We've been doing a lot of grouping based off of authors, but we could group things by the year they were released, or I don't know, the quantity we have in stock, or whatever we have, whatever available pieces of data we could group by. But grouping by author makes a lot of sense for calculating some sort of meaningful data. Next up, we're going to continue on with some of these aggregate functions, and we're going to, in particular, focus on sum, which will allow us to add things together, and average, which allows us to calculate averages. Oh, wait. I forgot I made this slide. I ended the recording and everything, started editing, and then I remembered I also have this slide here of a nice cleaned up version that just shows you can use things like max and group by along with concat. So all that this does is the same thing. It finds the longest page count for each author, but rather than just printing out this mess here, it's not really even a mess, but what it does is it combines some data, and it uses aliases so that we have author and longest book as our column headers, and concat to put together, as you've already seen, the author's full name. So just copy that, run over here, paste it, and there we go. We get author, longest book, and we have a full name here and their longest book. Yep, that's it. Now we're actually done. I promise. Alrighty then. It's a little enthusiastic. Well, next up, we're going to talk about sum, which is another built-in function. It does what it sounds like. I know I say that a lot, but it sums together data. It adds things together. Very exciting. It actually is pretty useful. You can do things like, I don't know, sum together all the profits, all the sales that you've made, or your entire payroll for a given month, let's say. You can find some important information using sum. For instance, you might want to sum all the pages in our entire database. So this is following the same pattern as what the last couple videos have. We're going to show you how to use this function on its own without group by, and then I'll show you at the end of the video how to use it with group by. So, okay, sum all the pages in the entire database. It's pretty simple. It's just a select sum pages from books. And it tells us 6,623. And that's all there is. We could do silly things like sum, go away, Siri. All right, we're back. So we could do something silly like a select sum released year, and that's just going to add together all the years in our database. Let's see, 37,996. Very important insight we just gained. Okay, so that's all there is to summing things on its own. Now let's see how we use it in conjunction with group by. It works the same way as what we've seen before. Basically, we group things together by whatever, let's say, author or, I don't know, year. And then we select what we want, and we can use sum to help us select. So select all the pages, or sum all the pages each author has written. Let's see which author cumulatively has written the most number of pages. Whew. So we'll start with a select, and let's do the same thing with author F name, author L name, and then we'll sum pages. So we'll do that from books, and then we need our all-important group by author F name, author. Actually, we need to do L name first, and then F name, just like that. And you can see, looks like Dave Eggers has the most, 1,293. Raymond Carver, 702. John Steinbeck only has one book, so it's only 181 pages. And that's pretty much it to sum at this point. We could, of course, do the same thing with, let's say, adding the release year for their books. Also a very insightful piece of information that we need, but we can see people who have multiple books, like Raymond Carver, there's multiple years added together. Yep, that's pretty much it. Okay, so that's sum. Like I said, you may end up using it if you're, I don't know, dealing with sales data or payroll, any sort of information where you're summarizing things. Actually, I just used it recently when I was compiling my taxes. Probably going to bore you to death with this, but I have a database that has sales data for every week for one of my projects that I have going on. And I just wanted to figure out exactly in a given year how many sales, or not how many, but how many dollars I'd sold in that entire year, and just add all those values together. I didn't want to, manually enter them into a calculator. So it was just a matter of using select sum. And I actually did a select sum with a group by, because I grouped by year, because I have sales going back, I think 2016, 15, and 14. So I only wanted 2016 for my tax season. Anyways, if you're still there, thanks for making it through that. I know taxes are not the most interesting subject, but yeah, some can be useful sometimes. Oh boy, I'm going to end it now. That was just bad. Next up, we're talking about AVG. AVG. Hang on. Next up, we're talking about average. And as you might have guessed, because I've said this for pretty much every video in this section, it does what it sounds like. Actually, that's a lie. It sounds like AVG, but what it does is average data. So it will sum things together and then divide them based off of how many things it added together. So it's pretty useful if you're trying to do things like find the, average sales for something in a given month, or find the average price of something in a database, or the average, anything, the average number of users or the average number of followers that your YouTube videos have. I mean, averages are pretty useful in general. Think of all the times in your life. Hopefully, maybe you never average things, but I feel like it's something I find myself doing. It's a lot of what teachers do is find averages, average scores, average grades. Okay, well, let's just get back to this. There are a lot of uses for averages. It's not a perfect way of getting insight. I don't want to say that, the average is this amazing, all-encompassing piece of data, but it can be useful. Anyways, so how do we use it? Also, as you might have guessed, I'm going to show you how to use it on its own first, and then how to use it with group by. By now, we'll be able to do this pretty quickly, and it should serve as review. So we could do something like this. Calculate the average released year across all books. And that's very simple. We do a select AVG, average, released year, from books. And as you can see, we get 1999.7895. And it's important to note, yes, there's a decimal, and it goes out to 4 places here. We'll talk more about different types of data types, in a coming section, where we'll talk about the differences between integers and the ways of storing decimals. But for now, it's important that you notice when you do average, it doesn't round things up to a whole number. It gives you 4 decimal points. We could also do things like select the average page count from all of our books, which is 348.5789 pages. Okay, so now let's see how to use it with group by. That's a more common application. How do we do something like calculate the average stock quantity for books released in the same year? So this is a little bit different. We're not grouping by author in this case. We have a couple of books that were released in the same year by different authors. And this is sort of arbitrary, very arbitrary, but how do we calculate the average stock quantity for books released in the same year? Looks like this. Select AVG, average stock quantity from books, group by released year. So let's try it. Select average, and we want stock quantity from books, group by released year. Just like that. Not that insightful to look at, let's be honest, but maybe we could do something like this. Let's print out the release year, the count, how many books were released that year, and then the average year. So it will look like, or the average stock quantity, excuse me. So we'll have released year. And then let's just leave it at that. Released year and the average stock quantity. And if I do that, you can see 1945, 95 is our average quantity. 2001, 134 is their average quantity. Yes, not that useful. I totally agree. But I just want to mix it up because we've been doing a lot of group by author L name, comma, author F name, and it gets kind of old. So we can group by other important pieces of data. But of course, we could do something like this. Select, let's do our good old author F name, author L name, and average. Let's do average pages written by every author, or each author. From books, group by author L name, author F name. Oh boy, it's a little bit too eager there. What's our problem? Looks like I'm missing a comma right here. Okay, so you can see the average pages written. We saw how to select the min and the max, as well as the sum. Now we have average. Also, it's important to note that someone like, let's see, John Steinbeck, who we know has one book, 181, it still adds the 4 decimal points. And that has to do with the data type that this is. And basically, I'm just going to punt that one until we talk about data types. But I just wanted to highlight it here. You still get those 4 decimal points, even if it's an even integer. Even not meaning, okay, that was a bad choice of words. Not as in even and odd. Let's say as a whole number. There we go. All right, so that's average, and that actually wraps up the section on, or the new content on these aggregate functions. So we saw count, well, we saw group by, and then count, min, max, sum, and average. All different things that we can do on their own or in conjunction with group by. All right, so now we're going to get another chance to practice it. Hopefully you're looking forward to that. And if you're not, it's still good to do. It's like, vegetables. You just got to eat them. I hope I don't offend anyone if you're a vegetarian. All right, welcome back. It's me and my cat. Can you purr? Say hi. Meow. That was my cat, I promise. So in this video, we're now going to spend some time, or you're going to spend some time getting some practice with the different functions we just saw. Things like count, min, max, sum, and average, as well as using them with group by. So in this video, I'm just going to lay out the challenges or the exercises, and then in the next video, we'll talk about solutions. So the first one is to print the number of books in the database. So, don't just do a select star from books and then manually go through and tabulate or count them. Write a single line that will print out the number of books in the database. And then once you've done that, move on to this one. Print out how many books were released in each year. And I have to say, the wording on some of these is not great, but I kind of struggle to figure out how to explain this the best way. Basically, group things by year that they were released, and then just print out how many were released that year or each year. So it should look something like 2005, 1, 2006, 2 books, 1945, 1 book. Now those numbers I just made up, so don't worry about those numbers, but basically that's the idea. You should have the year and then a count for how many books were released that year. And then, next up, print out the total number of books in stock. So there's a stock quantity, and every book has a stock quantity. So print out the sum. I just gave it away. Well, print out the sum of all of the books in stock. So just add together all the quantities. And then find the average released year for each author. So you'll need to go through, group things by author, first or last and first name, and then find the average year that they were released for each author. So your results should look something like Raymond, and then Carver, and then the third column should be the average released year. Let's say that's 1985.2 or something. Next up, find the full name of the author who wrote the longest book. So full name here is in a different color because it's a little different. This one, you'll need to use one of the tricks that we saw in that video where we talked about min and max and that issue. God, my cat's being a nightmare. Hey, come on. Blue. No, no. Oh my God. She's just knocking everything off my desk. Blue. Okay, so where was I? The idea here is to not just find the longest book or the page count for the longest book, but actually print out the name of the author, the full name. So you'll need to use concat, full name. We want first plus last name with a space in between of the author who wrote the longest book. So you need to find the longest book and then use that to find the author, basically. And there's a couple ways of doing that. If you remember the min and max video, that the second min and max video, where I talked about some of the problems, or one problem in particular that arises when you try and print information like title or author based off of something being min or max. And then the last challenge here is to print this data out. So we should have the year is released. Notice that we have an alias for all three of these. So the year, like 1945, the number of books released in that year. So, 1111. But then here we go. In 2001, there were 3 books. And then the average number of pages for those books released in that year. So I won't tell you how you need to group things in this case, but hopefully you can figure that out based off of this image. All right, I gotta take care of this cat situation. Oh my God. And then in the next video, we'll have a solution. Okay, so in this video, we're just going to go over the solutions to the exercises I introduced in the previous video. And the first one here is to print the total number of books in the database. So we'll need to use count. And all that we'll do is write a select count star from books, just like that. And we get 19. All right, and that's it. The next one is to print out how many books were released in each year. So we'll need to use a group by released year, and then use count in conjunction with that. So let's do a select, and we'll just do count star from books group by released year, just like that. Now on its own, this isn't that useful, so I'll go ahead and add in select released year, comma, count, so that we get the year was released and then the count. You can see most years have 1 book released. 2001 has 3, 2003 has 2. All right. So the next problem, print out the total number of books in stock. So this one, you'll actually need to use sum, and you'll need to sum all the stock quantities, which is something I guess we haven't really used. Whoops, that's not how you spell from. We haven't used stock. Oh, my cat. You gotta chill out, Blue. So stock quantity is not a piece of data that we've used very often, but it is here. We've neglected it a little bit, but it is there, as you can see. So we just want to add them all together. And that's just going to be select sum stock quantity from books. There we go. We have 2,450 books in stock. So the next problem here is to find the average release year for each author. So we'll need to group by author, and then we'll need to use average, AVG, to calculate the average release year. So let's give it a shot. Average release year for each author. So we'll need to do a select average and then release year from books group by, and then we're grouping by author. So we'll do L name, comma, author, F name. Again, because of the Harris issue. What are their names? Dan Harris and Frida Harris. Okay, so if we do that, oh my God, my cat again. Oh boy. Well, I've taken care of that, and I don't mean, wow, apparently I have not taken care of it. All right, hang on. So back to the problem at hand. this works. We're getting average years, but to make it a little bit better, we should also add in the author F name, comma, author L name, just so we can make a bit more sense of the data. So now we can see Raymond Carver's average release year is 1985. Let's see, Neil Gaiman's is 2006.6667. All right, so that's all there is to that problem. Now we get to the one that's a little different. Find the full name of the author who wrote the longest book. So there's a couple ways of doing it. The way that doesn't qualify as a solution, the two-step process, would be first to find the longest book. So that would be select max pages from books, like this, 634. And then, at this point, we can make a second query, select, and we want to concatenate first name and last name. So we do concat author F name, comma, author L name, and we want a space in between, like that. From books where pages equals 634. And there we go. We get Michael Chabon. However, we want to do it in one step. So we can either do the subquery route. So we'll do select concat author. However, instead of, we'll do from books, but instead of just doing where pages is 634, we'll do where pages equals, and then we use parentheses for the subquery. Hopefully you remember this part. And then in here, all that we do is write our query. So that's going to be select max pages from books. And we get the same thing, Michael Chabon. And then there's the other way of going about it, which is to not use max at all and circumvent that, which is actually faster to use order by and then limit it to 1. So we could do the same thing, select concat author F name, author L name from books, and then we just do an order by pages ascending limit 1. And I believe I have that backwards. We want the longest book, not the shortest one. There we go. So we want it in descending order so that we get the longest one at the beginning. And that's going to be 634. So if we get rid of this limit 1, and actually if we get rid of the limit 1 and let's do pages, comma. All right, so you can see now we've got 634 all the way down to 176, and I had it backwards. Okay, so both are valid ways of getting the solution. This one is a little bit, it's a little faster because we're running one query. This version is more complex, more advanced, I guess, but I would definitely stick to using this when possible, using order by. All right, let's move on to our final challenge here. Make this happen. So we've got a couple things going on. We've got a year, so we've got a year, the number of books in that given year, and the average pages for all those books for that given year. So things are grouped by year, and we have 3 aliases going on. Okay, so let's give it a shot. So we'll start off by selecting year, or released year, and giving it the alias of year. Then the next thing is the count. Remember, we're going to have a group by at the end. So we're doing all of this, writing the 3 things we're selecting before we actually have the group by. But at the end, we're going to have group by released year. So this here, number of books, is count. It's a count of the number of books released that year. So I'll indent and just do count star as. And I need quotes here because we have that octothorpe, I think is what that's called, the hash symbol, as well as a space. So we need quotes for our alias if we want to match this. Then we have average pages. So it's going to be the same thing as far as our alias is concerned. So we need average number of pages as, AVG pages. Is that correct? There we go. Okay, from books, and I'll indent this one too, group by, and we want to group by released year. Hit enter and pray. And it looks like it worked out. 1945 had one book, 181 pages long. Take a look at 2001. There was 3 books, and the average number of pages is 443 and a third. All right. So that matches what I had here, which means that we got it right. Don't ask why you would do this. Just don't ask. That's it for this section. And I'll see you in the next section.